Hey Algebra 1, this is the first video in a two-part series on how to solve absolute value inequalities. First part's going to cover what exactly does an absolute value inequality look like, and the second part is how to solve them. Okay? First problem we're looking at here are what numbers are 2 or more units away from 6. And what we want to do is we want to focus on what our center point is here. Okay, so in this case that's going to be 6. We're going to go ahead and put 6 in the middle of a number line here. And then we're going to take a look at what numbers are just 2 units away. So in this case, to the right would be 7 and 8, and then to the left would be 5 and 4. Okay, so in order to graph this, we want to take a look at, how would we represent that graphically? Okay, well, if it's 2 or more, so 8 is included in that 2, anything more to that would be to the right. Okay, same thing with 4. 4 is included because that's 2 away from 6, and then everything to the left. So 2 closed circles and then everything to the left and right of those points. Okay, this is what we saw before as an OR inequality when we talked about compounds. Okay, if we look at another example here, let's say we have all my numbers that are 4 or more units away from -1. Same thing, I want to put -1 in the middle, and then we kind of count out. So to the right would be 0, 1, 2, and 3. Okay, so 0, 1, 2, and 3. Those are my numbers that are 4 units to the right from -1. Then we go the opposite way here. So -2, -3, -4, and -5. Okay, so once again, the key here is 4 or more units away. So once again, we include that +3 and then everything to the right because that's more than 4 units away. And then same thing with -5. We go ahead and shade everything to the left. Once again, we're talking about 4 or more units away. That or more is a key. And this is going to be an OR inequality. All right. But on the flip side of that, let's say we have numbers that are 3 or less units away from 10. So we start with 10 in the middle. And we do 11, 12, 13. Those are 3 units away here. And then we go from the left side, we go 9, 8, and 7. Okay? Now, here's the difference between less or more. Okay? Once again, we still want to put closed circles over our extreme values here. Okay, or our boundary values more so. If we're talking about everything that's 3 or less, that's going to be everything in between, because if we look at 9 and 11, this is 1, this is 1. 9 to 8, or 8 to 10, that's 2, and 10 to 12, that's also 2, which fits the bill here. So that's going to be everything in between our two values, 7 and 13, which we recognize from our compound lesson as an AND inequality. Okay, this is important, trust me. Okay, and then the final example is what numbers are 1 or less units away from -5. Once again, we put -5 in the middle, 1 or less, so that's -4 to the right, and then -6 to the left. Okay, once again, 1 or less, so we put closed circle over the first, closed circle over the second, and then because it's 1 or less, that means we have to go everything that's shorter than 1 away from -5. And once again, we recognize that as an AND inequality. Okay? Now, there's a little bit of a convention here in terms of how we write the absolute value inequality for each one of these number lines that we have here. And here's the first example, again, rewritten so we can have a better idea. So what numbers are 2 or more units away? Well, we want to take the absolute value of x minus our start value, which is that center value. So in this case, it'd be x minus 6. Absolute value of x minus 6 is greater than or equal to how far we're going, which is 2. Okay, so I'm going to bring back the first example we did, which is right here, just with the number line here. So this is the absolute value, once again, of x minus 6 is greater than or equal to 2. Okay, so once again, 6 is where we start, so that's what goes inside the absolute value, and then 2 is how far we're going from that center value. This will result in an OR inequality. Okay, and the key here is that it's a greater than or equal to. So OR inequalities are always signified by the greater than or equal to. We're looking at the second example, 4 or more units away from -1. Here's how we would write this. Because we want to do x, the absolute value of x minus something, but it's negative, we'd actually write it as x plus 1. And then because it's an OR inequality, it'd still be greater than or equal to, and how far we're going, that tells me, hey, that's going to give me a 4. Okay, second example. Now we're getting into the and inequalities, okay? We still want to incorporate our center value, our start value, and our radius, so to say, if we're using geometric terms, okay, or how far we're going from that number. We still want to start with the absolute value of x, and because 10 is positive, we're looking at numbers that are 3 or less units away from 10. It would be x minus 10. And then now that we're doing and inequalities, now it's going to switch from greater than to less than or equal to, and then we put our distance right here. So this line right here will be represented by the absolute value of x minus 10 is less than 3. So once again, and inequalities are represented by less than or equal to. And then finally, this example right here, numbers that are 1 or less units away from -5. Because it's a negative, we write it as x plus 5 in our absolute value, and then it's and, so it's less than or equal to 1, which is that distance between there. Okay? This is just the first part of a video on how to write absolute value inequalities. Check back in the next video to learn how to solve absolute value inequalities.